Hi there, I'm Andrew Brown. Welcome to Real-Time Music and Sound with Pure Data. In this video we're going to be looking at modulation with low-frequency oscillators, with LFOs. This is a really nice technique for making sure that our synthesized sounds have some life and movement and activity in them. Digital synths like PD are often accused of being very sterile, and LFOs can be a good way to add some activity and some movement to those sounds. If we have a look at this diagram, you'll see what's going on. We're going to have an oscillator, which is listed here as the carrier frequency, the carrier oscillator. Then we'll have a second oscillator, which is the one on the top line in this diagram. And it will be modulating the carrier. That means basically it will be adding together with the carrier. And you can see the result below is different depending on whether or not we're modulating the carrier wave's amplitude or the carrier wave's frequency. And we'll be doing both of those things in this video. In order to get us started, we need to have a sound, and I'm going to use a phaser to create a sawtooth wave. So we'll give it a default frequency, and because the phaser is unipolar, goes between 0 and 1, we need to do some changes to it. Not that, we need to multiply it by 2, so that then goes between 0 and 2, and then we can add 1 to it, so it then goes between, subtract 1 rather, so that it goes between -1 and 1. So that the sound's not too harsh, because sometimes that can be, we'll add a filter. I'll use the VCF filter in this case with a default resonance of 1, which is low. And we need to give it a cutoff frequency, which comes in as a signal into this inlet, and as a starting point we'll set that to 500 Hertz. Okay, so there's our oscillator and our filter, and down towards the bottom here we'll add a kind of master volume control. Give it a small default value, and then that can go out to our DAC. There and there. Okay, so we initialize that cutoff frequency, and where we have our waveform, I will add a volume control for our master volume. We could go between 0 and 1, give it a label so we remember what it is. Okay, so that works fine. Alright, so now it's time for us to do a low frequency oscillator, which is of course just a normal oscillator. We'll use the sine wave or cosine wave oscillator default. And that needs to have a frequency, so we'll use a number box going into it to define that frequency. I'll give that a range low. We don't need to go below 1, and that doesn't really matter, but something high. And this is going to be our modulation frequency. We'll label that so that we remember. So that will set the frequency for our modulator. Now usually for a low frequency oscillator we want a very small frequency, so small that we can actually hear its effect. These oscillators are bipolar, going between -1 and 1, and that's fine, but -1 and 1 will only be a very small deviation to our frequency, which we probably won't even be able to hear, so we need to increase that. So we amplify that by some value, and that value will be the modulation index. And in this case, although it sounds a little counterintuitive, I'll get to it in a sec, I'm just going to leave that as, that's the modulation amount, I guess. I'm going to leave that as 0 to 1, which it seems like it's not making any difference. In fact, it sounds like it's getting worse. But we will multiply that, add that to the base frequency. And the base frequency in this case is 200 Hertz, but we can change that, of course. All right, so if we now route that to the frequency input, get rid of that, we can turn our volume up. And now if we increase our modulation amount, actually that's not going to work until we make that quite a bit bigger. Let's try that. Okay, so there we've got that vibrato. We can increase the speed. Okay, cool. Right, so I got slightly ahead of myself with changing this mod amount from 0 to 1. The reason that I was doing that, and I'm going to leave it like that, so now the slider stays between 0 and 1, is because we actually want to multiply that by the base frequency, which in this case is 200. The reason for doing that is that when we can then get a proportion, this will be between 0 and 1, it'll basically be proportion of the low frequency. That means that when we change the frequency of the actual oscillator, the kind of carrier frequency, then it will always be the same proportion of the carrier frequency, which is what we really want that to be. All right, so far, so let's try that again. It's all good. We can then decrease that and increase that, and that's pretty much the same effect. When we change our carrier frequency, however, we also need to update this frequency here. This 200 needs to change when this value changes. So I need to pass that value on. I'm going to use a trigger because I need to do a couple of things. I will pass the value on. The float value goes in here, so that will update that multiply when we change the carrier frequency. But we also need to recompute the modulation amount whenever we do that. So now we turn this up, then we can change this carrier frequency. And you can hear that whatever our carrier frequency is, our modulation is staying the same relative to that. Okay, so that's our frequency modulation. The next type of modulation we're going to do is amplitude modulation. At the moment our only amplitude control is this master volume, but I don't want to mess with that, so I'm going to add in an additional volume control in here, and this is the one that we're going to modify. The process will be very similar to what it was for frequency. We need to start with an oscillator. That oscillator needs to have a modulation frequency. In fact, I can just copy that one because it's already got our label and everything. This oscillator is bipolar, like all of them are, and our volume never needs to go negative. We can't go negative with our volume, so we want it only to be from 0 to 1, so we need to basically make this unipolar. So we can do that, for example, by adding 1 to it, which means it will then go between 0 and 1, and then we can divide that by 2, and that will make it go between 0 and 1, which is all good. So we've now got a unipolar oscillator. So now we need to say how much modulation depth do we want. We have a control over that, just like we did previously, and we can give that a value from here. This is our mod amount going from 0 to 1. Oops, put that on the other side. So this is all fine. It will currently, when we change this, if we set it like say 0.24, it will go between 0 and 0.2. Anyway, I can demonstrate that for you over here. Okay, so we have, let's make sure our frequency is not doing anything. If we increase, okay, so you can see that what's happening is we're going between 0 and whatever this mod amount is. What is kind of more useful is, instead of actually going always to 0, is to start from the maximum and go down, so that we just do a slight dip in the volume rather than always going to 0, because you're getting all these silence kind of portions in there. So we need to kind of invert that. So I'm going to use I'm going to use an expression box to basically, so we really actually want it to be 1 minus the what is it, LF1, 1 minus the input. Why isn't that? Oh, it's the, sorry, audio. And then that will, you can see now in our oscilloscope, and you can hear we're going from the maximum volume and dropping down 40%, and that's a much more sort of satisfying thing. And then when we go to 0 modulation amount, we're staying at our specified volume level, and when we increase it, we're doing a dip from our major one. Okay, so we have modulated the frequency and we've modulated the amplitude. Another thing which is common to modulate is the filter cutoff. Now that filter cutoff is going to be very similar in the process to our frequency modulation. So I'm going to start by copying and pasting that as the basis for what we're going to use for our frequency. This won't be our carrier frequency anymore. It will be our cutoff. Oops. Cutoff frequency. Can go from there to something big. Modulation amount is fine, and this number is arbitrary because we're going to override it here. So let's set that to something close to what we've got over here. So now we don't need our static frequency cutoff because we're going to use this one as a modulated one. Connect that over there, and let's see what that's doing. Okay, and we turn on, get a particular frequency, and then the modulation amount. Okay, so we are varying the frequency cutoff around the cutoff frequency, going slightly above it and slightly below it. And like we did with the frequency, we're using the cutoff and getting a proportion of that with the modulation amount, so that when we change the cutoff, for example, if we pull this down, we still get a change which is relative to the base, or the cutoff frequency that's specified. All right, that's all good. The final thing which I will change with at a low frequency is the bass pitch, the carrier frequency, and we want that to change from time to time to various chromatic notes. And at the moment we're just going to move it around randomly, and this gives me the opportunity to show you a low frequency oscillator of the type called sample and hold. So the ones we've done so far, they've used these sine wave oscillators. They could use different oscillators. They're constantly changing. The sample and hold provides a sort of pseudo-random outputs at whatever intervals you might want that to be. So because we're going to get some kind of pseudo-randomness, we're going to use the noise oscillator to generate those pseudo-random values. And from time to time we want to see what the value of that noise is. And there's an object we can use called snapshot. which will capture the current value of that noise whenever we bang the snapshot. And if I put a number box at the end of that, you'll see how this works. When I go bang, it outputs the number, the current value of the noise at the time of that bang. And sample and hold basically is going sample, 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 sample. And we'll just make sure that this value is sustained in between the samples. So that's all good. We were going to apply this to the base carrier frequency. And so you can see the range is as for all of these kind of oscillators, -1 to 1. So we're going to need to do some work on that to get it into this range. I'm going to first of all move it into MIDI pitch range as we go. So we need to do some changes there. So in order to make it unipolar, I'm going to be a little bit more efficient than I was previously on this. So it's the input divided by 2, which gets, and then multiplied by 0.5. And that will give us a unipolar output. We can just double check that. No, why are we still getting negative numbers? We shouldn't be getting negative numbers. Not multiplied by. We need to add 0.5. There we go. Okay, so that gets us between 0 and 1. In order to get this into MIDI pitch range, we'll do another expression. We'll take that and we will multiply our 0 to 1 to make it from 0 to 60. But 0 notes are very low in MIDI land, so we'll add 20 as an offset. So our range will be between 20 and 80. So this will now be MIDI pitches, but it's still going to be floating point. So we'll get, these quarter tones and stuff. So we can round that out by passing it through an int. And then this is MIDI pitches, so in order to get it into frequencies, we use the MIDI to frequency and then connect that up to our carrier frequency. So as we have our tone, whenever we take a sample of the noise, it's going to move us to a different pitch. So that's all good. We possibly don't want to have to sit there all day and keep clicking that, so I'll automate it with a metronome. And sample and holds usually have some kind of regular interval where they're sampling, so this sort of imitates that. At the moment we're doing it fairly slow at half a second, but this is about low frequency things, so slow is fine. So that's all good, and of course we can change that duration. Speed up or slow down that metronome. Okay, right, so the last thing that remains to do is to bring all of this together. So we have our sound. We'll introduce our frequency modulation, and then we'll introduce our amplitude modulation, and then we'll introduce our frequency cutoff modulation. How fast should that be? Pretty slow, I reckon. We'll move that cutoff frequency up so we can hear that more interestingly. So we've got a low frequency, very slow rise and fall of our cutoff frequency. We've got a reasonably regular amplitude going up and down, and all of our notes have a bit of vibrato. And then finally we can change our bass pitch with our sample and hold. can adjust the frequency of this sample and hold. Alright, so there we have it. Low frequency oscillators modulating various aspects of our very simple monophonic synthesizer. Have a go at that, and I look forward to seeing you in another video.